In the east coast of Fife lies the Eden Estuary. This estuary houses a vast mudscape which is uncovered between the tides and home to a variety of birds. However, there is one bird in particular that is extremely successful in dealing with the conditions of this environment. This documentary will focus upon that particular bird to reveal their secrets of success. Each bird searches the mud for prey using their beak, and each species' beak is a different shape to probe the sand in a specific way at a certain depth. For example, the dunlin has a short, slightly curved beak. The Eurasian curlew has a very long curved beak, whereas short, stubby beaks are common to both the golden plover and the knot. Unlike these other birds, oyster catchers have very long straight beaks to probe deep into the mud. The birds, with their different shaped beaks, must be probing the mud for a reason. Although these vast mudflats look derelict and lifeless, they're not. When scientists, such as ecology graduate Claire Savard, dig into the gooey mud, they can find many forms of life. Estuaries are actually highly productive, and the mud houses a hidden world of creatures. Including mussels, and worms like this ragworm. But what is it in particular that oyster catchers are searching for? Along with worms, oyster catchers eat cockles and mussels. But do all oyster catchers eat such a variety of prey? Perhaps individual oyster catchers have specially adapted beaks for certain prey types. When observing a large group of these birds, it is hard to see if they could be individually unique. To find out the answers, we go to the Zoology Department of World Museum Liverpool to speak to curator Tony Parker.
What we have on the bench is examples of some oyster catchers. We've got mounted specimens and what we call cabinet skins. And we can use these to show the different varieties of bills of these birds. The first one here has got a shorter, blunter bill. This is used for sort of hammering into sort of its prey. It will hammer through the shells of mollusks of various sorts so we can get to the meat inside. The second specimen has a sort of longer but also blunt bill. This is sort of more of a chisel which it sort of inserts into the muscle of the animal and sort of gets to the meat that way. The third example has a long pointed bill. This is used for sort of probing in mud and soil to get at worms and other invertebrates. These three bills are actually interchangeable within the bird, depending on the primary prey items within the habitat where it's feeding. The bills actually can develop within a matter of weeks from one form to another.
These subtle differences in beak shape allow the oyster catchers to change from feeding on soft worms to hard-shelled mollusks. We now know the secret to how oyster catchers feed successfully by developing different beak shapes to adapt to changes in food availability. Another secret for success is the oyster catcher's defensive alarm call, used when danger is near. If the birds are not quick enough in response to the call, it could be fatal. One gets plucked from the air by a buzzard, but this time escapes relatively unscathed. The final secret for success is the bird's ability to move with the constantly changing tide. The oyster catchers feed when the tide moves up, and rest at high tide when the precious mud is submerged until the tide moves back out and the feeding grounds are revealed once more. An estuary is a strange place between land and sea. To live in this constantly changing environment, oyster catchers have had to adapt in order to survive. Scientists have discovered that by adapting beak shape to combat changes in prey density, using calls to avoid predators, and moving with the tides, oyster catchers are able to thrive in estuarine mudflat environments. But perhaps there are still more secrets to be uncovered in the future about why this bird in particular proves to be such a success.